Hello
everyone, and welcome to this webinar dedicated to the new standard EN 17956, a game changer to lower the carbon footprint in industry. I am Michelle Gravelin, and I am Marketing and Communication Manager for the Technical Insulation business at Saint-Gobain. Before we dive into our topic, let's take a minute to introduce Saint-Gobain Technical Insulation. Our organization operates across 4 key technical markets, providing sustainable insulation solutions for industry, marine and offshore, HVAC, and OEM. We are present worldwide through our 2 international brands, Isover and Cayman, and through a network of local brands. Our strength is that we are both global and local, as we have a lot of local teams, local production sites in many regions of the world. We are experts in the area of insulation materials. It starts with mineral wool, such as gloss wool, stone wool, ultimate or light stone wool, and we also propose elastomeric foams. Now, the topic of the day. This webinar will be divided into 3 parts. The very first one, the presentation of the new standard, then the analysis of the positive impact of these new standards in industry, and we will end this webinar answering your questions. For those questions, you can see on your screen on the left the QR code. So this is the first possibility for you to ask the question. Just take your smartphone and then scan this QR code. It will be displayed during all the webinar. Second option, you can also type your question in the comment section of this LinkedIn page. Now, let's start. I am delighted to invite and welcome our 2 expert speakers, Juan José ORTA and Fabien KERVEADOU. The floor is yours.
Thank you, Michelle. Thank you, Michelle. Thank you, Michelle. Good morning, Juanjo. Welcome, everyone. Welcome to this webinar. I'm pleased to introduce today my colleague Juanjo, our international expert in industry, and he will be sharing today his extensive expertise on that topic. But without any delay, and to start with the webinar, I will ask you a very simple question, Juanjo. Could you explain to us the importance of decarbonizing industry?
Thank you so much, Fabien. Let's understand why decarbonizing the industry is so vital. Industry activities are the big source of greenhouse gas emissions and contributing to the climate change. The global energy-related CO2 emissions grew 1.1% in 2023, increasing with 400 million tons, reaching a new record high of 37.4 billion tons. Now, the industry worldwide face the urgent challenge to mitigate the impacts of this climate change. For example, in 2023, the European Union approved the Fit for 55 package, a series of proposals to try to mitigate the effects of this climate change, increasing or improving the energy efficiency, trying to reduce the CO2 emissions by 2030 by a 55% compared with the levels of 1990 levels. Probably Europe will be or will become the first climate neutral continent in 2050. One of the ways to reduce CO2 and improving the efficiency, energy efficiency, is especially the reducing the heat loss. However, many, if not most, companies are not aware about the technical insulation potential to try to improve the energy efficiency and reducing the heat loss.
So it's clear that decarbonizing the industry is crucial for fighting climate change. But now, could you explain why we have no game-changing effect on technical insulation?
Yes, until now, the technical thermal insulation is designed according to operational requirements, for example, safety requirements with temperature or surface temperature below 60 degrees. Most often of the existing insulation and technical requirements and only focus on process needs with this type of safety requirements of temperatures below 60 degrees. In other occasions are based on economical aspects as the lifespan of the industrial plants, the initial investment cost, but now many industrial plants are aging and they need an urgent insulation repair. Our experience shows that the energy efficiency levels in insulation in industry installations in Europe is relatively low. Despite this, there is a growing need to try to mitigate the effects of climate change. And in this point, this is where the new EN 17956 comes into play. With this standard, we have a new challenge, we have a new method to try to reduce the CO2 emissions, reducing energy consumption. And this standard will support energy management, and it could be possible to create a new specifications in industry without independent of the insulation material.
Okay, so if I understand you correctly, the new standard introduced an approach that may change drastically insulation design. But what is the current situation in Europe? Are all the countries experiencing the same situation?
No, it's not the same situation in the countries in Europe. Let's take an example to check the current technical insulation in Europe. We can take an example, for example, with a flat surface or the wall with a temperature, operating temperature at 200 degrees. If we use this type of standard and we have a safety requirement of surface temperature of less than 55 degrees, the most of European countries are with energy efficiency class G. Other countries with the national regulations and with the best practices in insulation could be in class F or class E or even class D, always taking into account that the country best practices in insulation, but the future objective with this standard will be to have energy efficiency class C, B, or A, focus in reducing CO2 and reducing heat loss, meaning having to be in the green zone of this classification.
So the new standard should provide a unified approach for the industry. This is really an excellent news. But then, what are the main challenges we must overcome to achieve this ambitious goal?
Okay, similar to energy labels in household appliances, the industry is introducing A to G labeling. This standard provides a uniform method for classifying the energy efficiency in the insulation system, mainly focusing on resources efficiency. This standard defines a classification method for technical insulation system where the energy efficiency class specify the maximum permissible heat flow rate. This type of heat flow rate is based on operation temperature of the elements and the geometric shape of them. But this standard, the journey began in 2018 when the BDI 4610 was published in Germany, and after several years working on different national committees, in 1st December 2024, the EN 17956 was published in Europe.
Okay, perfectly clear. But who is concerned by this standard in our industry sector?
Yes, this standard covers all technical installation systems in operational installations in industry and the building systems. This standard contains methods to calculate the energy efficiency class for insulation systems with different components such as pipes, ducts, vessel, tanks, with operation temperature between minus 30 degrees to 650 degrees. This standard is addressed for asset owners, mainly energy managers and maintenance supervisors, engineering company when they have to specify future projects, and of course, insulation contractors. Insulation energy efficiency class are determined using the life cycle approach. It takes account all greenhouse gases emission from the manufacturing of the insulation to the operation of the industrial plant.
With all these standards come also new concepts, new requirements, right? Could you explain a bit more about them?
Yes, in this standard appears a new concept, is the ecological optimum point. The greenhouse gas emissions are calculated for the manufacturing of the installation of insulation. This is the light blue curve, and the gas emissions during operation of the plant is the red curve. The ecological optimum point is the lowest total greenhouse gas emissions in this curve. Of course, if we manufacture thicker insulation, increase greenhouse gas emissions, and install thicker insulation, we can reduce heat loss on the operational emissions. These standards, the classification of energy efficiency class go from A to G, class A being the most energy efficient and G the least. Each class is necessary to calculate for each class the maximum permissible heat flow rate and correspond to a percentage up to the ecological optimum. The maximum heat flow is calculating with the operation temperature of the elements, the geometry of the elements, and under standard conditions. For example, class A represents 20% more than the heat flow rate of the ecological optimum. Other example, class C is the 55% more in heat flow rate than the ecological optimum. In this case, G represents the heat flow rate higher than class F. Normally in Europe, the most current insulation in Europe is class F or class G. We are in the red zone of the classification.
We need standardized conditions to evaluate energy efficiency. Are these defined in the new standard?
Yes, there are some standardized conditions in this standard. The third main conditions are it's necessary to take into account 10 years lifespan of the project, 6,000 annual operating hours, an average temperature of 15 degrees, and using average date of insulation materials and common fuels. But the more important thing is these conditions are only used to determine the energy efficiency class and the maximum permissible heat flow rate. If you adopt this type of standard, you can compare different insulation solutions independent of the energy price, and you can make all the installations comparable. And it's possible to take or to make decisions to optimize the insulation practices in your industrial plant.
I'm pretty sure there is some calculation to be made according to this standard. Can you explain how to use this standard in a simple way?
Yes, enter into detail about the workflow of calculation with this standard to determine the energy efficiency class of the insulation system. We have some steps. In this case, we have 5 steps. The main target of this calculation is to try to calculate the maximum heat flow rate of each energy efficiency class. The first step is to try to calculate the geometry coefficient. The next is the application coefficient, depending on the operation temperature, if this is for hot application or if this is for hot cold applications. The next step, step 3, is to calculate the energy efficiency class coefficient. Finally, we have 2 more steps to calculate what is the more or less the space requirement for the new insulation. And finally, the most important part is calculate the maximum permissible density of heat flow rate for each energy classes. For cold applications, it's the same procedure than hot application, but in the second step, it's necessary to include new expressions only focused for cold applications. This is a new procedure to calculate or to try to propose insulation solution. But for example, we have now, until now, we use only the ISO standard 12241, and now we have to introduce some calculations before with this new standard. In the phase 1, it's necessary to define what type of energy class we need, A, B, or C. Afterwards, check the operating temperature of our system, pipes, vessel, and geometry of the elements, and calculate the maximum permissible heat flow rate. Afterwards, at the current calculation that we did before, it's necessary to design the insulation solution. To design the insulation solution, we have to check or to define the material, the thickness, and the installation conditions. And we have to calculate the heat flow rate for right or real ambient conditions, ambient temperature, wind speed, etc. And compare the heat flow rate of our solution and the heat flow rate indicated by energy efficiency class. Our solution will have lower heat flow rate than the indicated by the standard or by the energy efficiency class. And finally, it's necessary to check some other requirement as process, for example, temperature drop at the end of the pipe, the safety or the surface temperature, maximum surface temperature, and to try to avoid condensation. As a conclusion, we can say that this standard is a vital resource to achieve energy efficiency in industrial systems, in installation systems. You can optimize your insulation solutions to meet energy performance needs, achieve cost savings, contribute to reduce the impacts of the climate change. It's possible to predict the CO2 emission reductions. You can predict the energy savings prediction, and other important thing is all insulation solutions are comparable with this standard. But the main thing that I want to say is the first time that we have a standard that introduce a limitation of heat loss. Now, if the industry in Europe are more or less in class F in terms of technical insulation, emitting great quantities of CO2, and technical insulation is we have a big potential with technical insulation to reduce CO2 emissions and to try to achieve this target. We can go to class C. In case of we reach class C, the reduction of the CO2 in Europe could be 44.8 million tons.
Thank you for all this detailed explanation, Juanjo. Now I think we can switch to the practical case and show all the benefits of the new standard. And I'm pretty sure you have some good example to share with everyone.
Yes, if we start with an example, a pipe. Now the procedure of calculation has changed. Before only use the ISO standard 12241 to design the insulation, but now we need to introduce a previous calculation with the new standard. With the new standard, we have to define what type of energy efficiency class we want to reach. In this case, energy efficiency class C. We have a pipe with operating temperature is 200 degrees, diameter 219 millimeters, and the maximum heat flow rate that we have to reach to get energy efficiency class C is 80 watts per meter. When we define the energy class, in this case C, and the maximum permissible heat flow rate, we have to go to the calculations with ISO standard 12241. In this case, we have to define what type of material we need to propose. In this case, we have proposed 4 different solutions. The two first ones, it's a stone wool solution with pipe sections and wire mats with final insulation thickness of 110 millimeters. And the last one is with new generation of mineral wool ultimate with pipe sections and wire mats 100 millimeter thickness, all calculated under the site or the real conditions. In this case, ambient temperature 20 degrees and wind speed 2.5 meters per second. If we improving the energy efficiency class, you can reduce CO2 emissions. We have 2 examples with the pipe. If we are going to class F to class C, we can reduce the CO2 emissions 45.8%. If we are going from class E to class C, we can go with a reduction of 32.7%. I know that the industry doesn't know the potential of technical insulation to decarbonize the industry. This is a real example to try to convince to the customers that the technical insulation has a big potential to decarbonize the industry.
Okay, let's continue with a second practical case, maybe with a storage tank.
Yes, this is a sample of a storage tank with a scenario, tank dimensions 14 meters of diameter and 12 meters height, with a fluid temperature of 45 degrees. We can take two ways. One, energy efficiency, other, the current insulation. In the case of the current insulation, we can install 80 millimeters thickness of insulation, and we can reach energy efficiency class D with a heat loss 13 watts per square meter. And if we take other way, in this case, the energy efficiency scenario, we can go to energy efficiency class A with 160 millimeters with a heat loss of 7 watts per square meter. We can get a reduction of emissions of CO2 of 40%, but not only reducing energy losses, therefore saving money on energy consumption, and also reducing CO2 emissions. Therefore, we can reduce the cost of or taxes of this type of emissions.
Is there any tool from Saint-Gobain we can use to manage this kind of calculation?
Yes, of course. To assist this calculation, I am happy to announce the new release of the software called TechCalc. It's the new TechCalc 3.0, probably before April. Is the unique software where you can make many kind of calculation. For example, you can compare different insulation solutions with an open database. You can compare different insulation materials. You can assign the energy efficiency classes. You can calculate the energy losses and reduction or the reduction of savings of CO2 for multi-layer insulation solutions. Then we can say that these two standards will be in the same tool, the EN 17956 and the ISO standard 12241, the last version, the 2022. Other features, we can assess the CO2 cost with different types of energy primary sources, and to create different tables of thickness for all types of diameters of pipe under certain fixed conditions.
Indeed, looks really a useful tools, Juanjo. Thank you for your time, all the explanation. I think we can now move to some question, if there is some question, of course. So let's go to the question. Okay, so here's some question in front of us, Juanjo. Okay, let's start with the first one. Is the standard EN 17956 mandatory in European countries?
And now yet, but the use of this standard, it's recommended by some countries in some companies in Europe since the last year. Probably in coming years, the European Union will propose the use of this standard to be mandatory.
Okay, clear. Thank you, Juanjo. Now we have a second question. How will the standard influence the design and implementation of insulation solution in industry in the future? I think this is a good question for you.
Yeah. For future industrial plants, it will be necessary to predict the space to these new insulation solutions, and it will necessary to develop a new advanced materials and to try to improve the techniques to install the insulation, reducing the thermal breaches as much as possible.
Okay, a new question. What about the cost? Important question, of course, because increasing cost will be a blocking point to apply.
Yes, of course, we will have additional insulation costs, of course, but we will have many benefits in long term. The first is the energy savings. If you increase the thickness of insulation probably you increase the cost, but you reduce the energy consumption of your plant, the CO2 emissions will be reduced, and of course, the cost of the taxes of this type of CO2 emission will be reduced. You will be improving the efficiency in your industrial plant, and of course, we can increase the lifespan of the equipment in the industrial plants.
Okay, thank you, Juanjo. New question: when new TechCalc will be shared? So I'm pretty sure they are mentioning the new TechCalc version 3.0.
I hope to be launched before April. If we are trying to solve some different arguments inside this type of standards to try to comply all the requirements, but probably in the first quarter of 2025.
Okay, so in the coming months.
In the coming months.
Okay, perfect. Let's wait if there is new question. Few seconds. Yeah. Okay. Generic question: will you share the presentation?
Yes, we will share the presentation and the video from this webinar, of course.
Yeah, I think it will be even in the technical installation website, but I'm pretty sure that our colleague Michel will share all the necessary information to get the presentation. Let's wait if there is new question. No more question? Okay, perfect.
I think that was the last question indeed.
Last question? Okay, yeah, I see it. So yes, Juanjo, last question for you. Will the full version of TechCalc 3.0 be online or with local installation?
Yes, we will have two versions. The two versions will be online. The first version will be free for everyone around the world with limited access to the features or the functions or the calculations that you can do. And with the second full version, it will be online too, but you will have all the functionalities, all the functions of this TechCalc with a licensed code.
Okay, clear. Thank you. New question again. So are the energy efficiency class with the watt per meter included in the 17956 equal than the indicated in VDI 4610?
Yes, of course. It's more or less the copy paste of VDI 4610 included in the 17956. It's the same energy efficiency class for all elements in the industrial plants.
Okay. Thank you.
Thank you very much. Thank you very much, Juanjo. Thank you very much, Fabien. So this is the end of the webinar. What we would like now to share with you is if you have some more questions, just simply contact us. You will have very soon in the comment on LinkedIn the link so that you can contact us directly. You can also download our brochures. And if you have enjoyed our webinar, we invite you to subscribe to our LinkedIn page so that you can receive all the invitation for the next communication, webinars, and so on. Thank you so much and see you soon.
Thank you, everyone.
Thank you.